Few places on Earth have a landscape as instantly recognizable as the Grand Canyon. You know it even if you've never been there yourself. But this vast chasm wasn't carved out in a day. This is how one of the most iconic scars on the face of our planet was formed over millions of years. The Grand Canyon is located in the state of Arizona in the north-central part of the country. It's within this region known as the Colorado Plateau. This area of Arizona is characterized by flat-lying sedimentary rocks that are tilted slightly to the west and all facing generally the same direction. The oldest rocks on the east side of the plateau are Paleozoic sedimentary rocks, which means they were formed from the deposition of sediments on the surface of the Earth. And these sedimentary rocks were deposited in a shallow inland sea called the Zuni Basin. As the sea spread westward, it covered much of what is now southwestern United States. These sediments, which came mostly from the weathering and erosion of nearby mountains, settled out on the bottom of the sea where they were compressed into layers of rock. Many of these layers are limestone, shale, and sandstone. Meanwhile, farther to the northwest, another sea called the Ancestral Sea covered parts of what are now California, Nevada, and Utah. And similarly, sediments rained down into this sea and formed layers of rock, though somewhat different than those in Arizona. For example, there are more layers of shale and chert here. Over time, this sea would eventually evaporate away, leaving behind thick deposits of salt. These rocks would later be uplifted and tilted onto their current west-facing angle. This angle created a sort of ramp for the next chapter in the story to begin. A series of large faults started forming along the eastern edge of the ramp. The movement along these faults pushed up huge blocks of rock, like this one called the Unker Plate, and this uplift caused even more layers of sediment to rain down atop the others, forming even more rock. Much of this sediment came from the newly uplifted areas themselves as the constant movement along the faults scoured and eroded these elevated regions. These newer layers include the massive tapetes, sandstone. At this point, the stage was set for the final act. For the Colorado River to stride across the stage and carve out the Grand Canyon. The Colorado River is the lifeblood of the region. Water from snowmelt in the Rocky Mountains flows through the river, which then travels across the Colorado Plateau. Much of this water eventually makes its way to the Gulf of California. Along its path, the Colorado River has cut a deep gorge through the stacked layers of sedimentary rock. The river began carving out the canyon several million years ago. However, the rocks in the canyon walls indicate that the process really picked up pace about 5 to 6 million years ago. At this time, the river was given even more power by the uplifting of the Rocky Mountains. As the Rockies rose, the slope of the land to the west of them increased, causing the Colorado River to flow more quickly and with more energy toward the Gulf of California. Today, the Colorado River is still busy carving out the Grand Canyon, lowering its channel by about 1 and 2 meters every 100 years. The energy of the river is so strong that it is able to completely rearrange some parts of the canyon's landscape in just a few days during the annual flooding season. Most of the rocks exposed in the canyon walls are sedimentary rocks, and many of these sedimentary rocks have been dated back hundreds of millions of years. Because the Colorado River is so busy carving out new rock surfaces, it doesn't give these rocks much time to weather away. Thus, these rocks preserve a detailed history of the Earth on the walls of the canyon. In general, the older rocks are found at the bottom of the canyon, and the younger rocks are at the top. So when you're standing at the rim of the canyon looking down into it, you are literally looking back through time. In other words, you are witnessing the history of the Earth being exposed for miles in all directions. You can see individual layers of rock in the canyon walls, each with their own color and texture. Each layer tells a unique story of the conditions under which they formed. For example, the bright red-colored layers, such as the Shinerump conglomerate, are made of large angular fragments cemented together. This type of rock is called a conglomerate, and these conglomerates form in fast-moving streams. Thus, we can tell from this rock that the stream that deposited it was moving pretty fast. On the other hand, the very fine-grained sandstone such as the Moncopy Formation indicates a slower-moving body of water, perhaps a lake. We can also decipher clues about the environment from the chemical composition of the rocks. For example, the white color of the Nankat's quartzite suggests that it is mostly made of quartz, but little else. Quartz is chemically stable and often forms in warm, shallow waters. So this rock tells us that the environment it formed in was probably warm and shallow. Some of these layers contain fossils, and by studying the fossils, we can learn even more about the environment. For example, in the upper layers of the canyon, you can find marine fossils such as trilobites, brachiopods, and mollusks. These types of fossils indicate that at the time these rocks were forming, the environment was an ocean. Other layers of the canyon contain fossils of terrestrial animals, such as amphibians, reptiles, and early mammals. These fossils indicate that at the time these rocks were forming, the environment was more like a swamp or a forest. Still other layers contain even older fossils. Some of these fossils are so old that they date back more than 500 million years. The Grand Canyon is not only filled with ancient rocks and fossils, but also with amazing plants and animals. The Grand Canyon is home to a variety of ecosystems, including forests, deserts, and grasslands. These ecosystems support a wide variety of plants and animals, many of which are found nowhere else on Earth. For example, the Grand Canyon has its own species of squirrel, lizard, and fish. The canyon's diverse ecosystems are made possible by its complex geology. The different layers of rock create a variety of habitats for plants and animals to live in. For example, the shady cliffs provide habitat for plants and animals that need shade and moisture, while the sunny slopes provide habitat for plants and animals that need sunlight and warmth. The canyon's geology also affects the types of soil that are found in different parts of the canyon. These soils support the growth of different types of plants, which in turn support different types of animals. As you explore the Grand Canyon, you will see evidence of its unique geology everywhere. From the layers of rock in the canyon walls to the types of soil in the different ecosystems, the Grand Canyon's geology is what makes this place so special. Its ancient rocks and fossils tell the story of our planet's history, and its unique ecosystems are home to a variety of plants and animals that are found nowhere else on Earth. Thanks for watching this episode. If you want to help us make more videos like this one, please consider becoming a patron. And if you want to watch more of our videos, you can do so here. All the best, and see you next time.